Welcome to another tutorial on Danfoss VFD. In today's tutorial we will see how we can maintain water pressure in the pipe using a closed-loop PID control function in the Danfoss FC51 inverter. We have installed two-wire pressure transmitter in the water pipe line. This sensor will sense the water pressure in the pipe and give the pressure feedback 4 to 20 mA analog signal at the analog input of the VFD, and based upon the difference between the current pressure and the setpoint pressure, the VFD will increase or decrease the RPM of the three-phase pump motor to bring the current value of the pressure closer to the required setpoint pressure. Before starting, I would like you guys to please subscribe my channel and press the bell icon to get the notification of the new uploaded videos. Let's see the wiring for today's tutorial. If we open the panel box, here you can see that we have installed a FC51 inverter. If we open the front cover of the VFD, here you can see the control terminal block of the VFD. We have connected two red wires at terminals 12 and 18, and other ends of these two wires are connected to a normal open selector switch. Terminal number 12 is the 24-volt DC common, and terminal 18 is the first digital input of the VFD. Terminal 18 is configured as the start command of the VFD. Next we have connected an orange wire at 12 number terminal, and white wire at the terminal 60 of the VFD. Terminal 60 is configured as the analog input. These two wires, orange and white, are connected to the two-wire analog pressure transmitter as shown in the diagram.
Motor cable is connected at U, V and W, VFD output terminals.
Voltage will be applied to the motor through these terminals. Now the wiring is completed. Next we have to modify some VFD parameters to enable the PID function of the VFD. First we will set parameter 1-00 to 3, this will configure VFD run mode as closed loop process PID. Next set parameter 1-01 to 0, his will configure VFD for special motor functions. Next we will set the motor nameplate parameters. Set parameter 1-20 to 1.1, this will set the motor power to 1.1 kW. Set parameter 1-22 to 380, this will set motor voltage to 380 volts. Set parameter 1-23 to 50, this will set motor frequency to 50 Hz. Set parameter 1-24 to 2.8, this will set motor amperes to 2.8. Set parameter 1-25 to 2800, this will set 2800 motor RPM. Set parameter 3-03 to 3.0, this will set maximum setpoint for the VFD. Now the VFD will try to keep the pressure at 3.0 bar. Set parameter 3-10 to 100, this will set preset reference as 100%. Set parameter 3-41 to 3.0 seconds, this will set the ramp-up time 3.0 seconds. Set parameter 3-42 to 10 seconds, this will set the ramp-down time 10 seconds. Set parameter 4-10 to 0, this will allow motor to run in forward direction only. Set parameter 4-14 to 50 Hz, it is maximum output frequency of the VFD. Set parameter 4-16 to 250, it is the torque limit for the motor. Set parameter torque limit 4-17 to 250, it is torque limit generator. Set parameter 5-10 to 8, it will configure terminal number 18 as start input. Set parameter 6-22 to 4.0, it will set analog input terminal 16 low current to 4.0 mA. Set 6-23 to 20.0, it will set analog input terminal 16 high current 20.0 mA. Set parameter 6-24 to 0, it will set the scale the low limit for the pressure sensor signal as 0.0 bar. Set parameter 6-25 to 10, it will set the scale the high limit for the pressure sensor signal as 10.0 bar. Set parameter 7-20 to 2, it will set analog signal from terminal 60 as process feedback. Set the parameter 7-33 to 2.0, it will set the proportional gain as 2.0. Set parameter 7-34 to 6.0 seconds, it will set the integral time as 6.0 seconds. Now parameter settings is completed here. Now let's start the pump and see how PID function works. As we turn on the selector switch, the VFD gets a run command at the terminal 18, and slowly ramp up the pump and pressure starts to rise inside the pipe. The VFD output frequency goes to the almost 45 Hz and pressure reaches 4 bar, but the set point pressure is 3.0 bar. The PID functions reduces the pump frequency and bring it down to 42.8 Hz, where we get our required set point pressure 3.0 bar. PID function will try to maintain the 3.0 bar pressure by regulating the RPM of the pump. So, this is how we can use the PID control closed loop function of the Danfoss VFD. I hope you liked today's video. Please share, like and subscribe this channel. Till next time, take care and goodbye.